Hey folks, I've had a couple of you ask about this problem. This is a MyMathLab question. I'm not sure of the exact MyMathLab problem number, but if you look at the nomenclature up here, it'll tell you which one it is. It is from section 3.9, but I'm not sure which problem number it is in the homework. But it is number 53. So just look at the title. So we're asked to find the derivative of the function f at a given value of a. In this case, we're going to use a equals pi over 2. So what's complicated about this problem? Well, if you notice, this looks like an exponent, right? We've got this exponent here, sine of x, all to the natural log of 10x. So it is an exponent, but notice that the base has a variable in it, and the power has the same variable x in it. So this is one of those examples where you cannot use the power rule, nor can you use the exponential rule. Neither of those apply when both the base and the power have exponents or have variables in them. So this is from section 3.9, where we introduced a technique called logarithmic differentiation, and so we're going to have to use logarithmic differentiation on it. Okay, so just for the simplicity of notation, I'm going to go ahead, we were given the function as f of x equals sine of x all to the natural log of 10x. I'm going to go ahead and rename this y, just so it fits with your notes how we labeled most of these problems. Okay, so if you remember, what's our next step? Well, our goal is to separate this base right here from this exponent. How can we do that? Well, natural logs are a good tool, or logarithms in general are a good tool to help using, but with properties we can separate bases from powers. So I'm going to go ahead and take the natural log of both sides. We'll slow at this. Oops. Natural log of the sine of x all to the natural log of 10x. And be careful here, there's a few different natural logs at play in this problem, but I think we'll be able to get through it just fine. Okay, so let's just take a moment to rewrite it. We get the natural log of y, and this is why we did this procedure. This is why we're doing logarithmic differentiation, because what can I do now? For this exponent, I can go ahead and pull the power of the exponent out of the logarithm through multiplication. So that gives us the natural log. So the logarithm that's coming out is the natural log of 10x times the natural log of the sine of x. Okay. So now we're ready to go ahead and do some calculus. So let's differentiate both sides through the technique of implicit differentiation. So when we do so, we get 1 over y times y prime equals, and let's pause for just a minute to remind ourselves why this implicit differentiation works. So, or why we're doing implicit differentiation. I no longer have an explicit function of y because I've taken the natural log. This is now some larger equation involving y, and y is not explicitly solved for. So when I go to take the derivative of the natural log of y, well, the derivative of the natural log of any expression is 1 over that expression. But because the expression inside the logarithm is more complicated than just an x, I have to incorporate the chain rule. So I do write 1 over the expression, but then I need to multiply that by the derivative of the expression. Since we don't want to replace that with y itself, we just go ahead and write y prime there. Okay. Now we're ready to continue. On the right-hand side, I've got a product rule. So here we go. Here's the first. Oops. Here is the first times the derivative of the second. Now careful, I now need to multiply that by another chain rule. When I took the derivative of the sine of x, it is 1 over the sine of x, but because the expression inside the sine was more complicated than just an x, I had to multiply by the derivative of that expression. Okay. So let's get caught up just a little bit. We're calling this the first of our product. This is our second. So here I've got the first, and then all of this is my d second, the derivative of the second. And now I'm adding to that the second, which is the natural log of the sine of x, times the derivative of the first. Well, what's the derivative of the first? It would be 1 over 10x times 10. So let me just get caught up with labeling. This was the second, and then this is the derivative of the first. So let's look at that derivative of the first term. It again is a chain rule. I'm taking the derivative of the natural log of 10x. Well, the derivative of the natural log of an expression, it's 1 over that expression. But because the expression inside the logarithm was more complicated than just an x, I had to multiply it by the chain rule by the derivative of that expression. Well, what's the derivative of 10x? It's 10. Okay. So let's clean this up a little bit. Before I take the y over to the other side, let's just see what we can do to rewrite this. I think this gives me the natural log of 10x times, careful, the cotangent of x. Why is that the cotangent? Because when I multiply cosine to 1 over sine, I get cosine over sine, and I recognize, oh, that's the reciprocal of the tangent, so it's the cotangent. Plus the natural log of the sine of x, that's an n there, all over x. So these two 10s would cancel, and then I've got natural log sine x times 1 over x, so I just went ahead and put it all over x. Okay. Getting close to finishing. We're trying to find out what y prime is, so let's go ahead and multiply both sides by y to get the y prime isolated. So we get this, okay. And then since our function actually was given to us by the name of f, I'd like to return to that. So let's go ahead and call this f prime of x is equal to, and then what was y? Well, y was just the original function, so I'm going to replace y here with the sine of x all to the natural log of 10x. All of this, let me just make sure that's clear, all of this right here is a substitution, a back substitution of what y was holding the place of. And then I'm simply going to copy down the product. So we've got times, this is a little bit, let me see if I can insert some space here. I kind of goobered the space. There. Times the natural log of 10x cotan x plus the natural log of sine of x over x. Now there may be some simplification I could do to this problem, but I think that's a good place to park the answer, and my math lab should accept that. If it doesn't, please let me know. All right, folks, I hope that was helpful, and if not, send me an email.